Hello, welcome to Flipped IGCSE Biology, Unit B7, Coordination and Response, Lesson 2, the eye. The eye is basically an extension of the brain. You can see they're very, very close together here. Now information is taken from each eye down the optic nerve to a different side of the brain to be interpreted. You'll notice that the information from the right eye goes to the left side of the brain, and the information from the left eye goes to the right side of the brain. Here we have a cross-section of the eye. So various different parts that you need to know about here. We've got the retina. That's where all of the light arrives to. It's the light-sensitive layer or part of the back of the eye. You've got the lens. The lens, as you can imagine, is used to focus the light that arrives at the eye. We've got the cornea, which is also involved in focusing of the light, and it protects the front of the eye. We've got the sclera, or the sclerotic, which is the white outer layer of the eye, and the optic nerve, which takes the information from the retina to the brain. The suspensory ligaments, which are attached to the lens, and the ciliary muscles, which contract and relax to change the size of the lens. First of all, let's look at the retina in more detail. This is an actual real picture of somebody's retina. You can notice here the optic nerve, that's the point where the optic nerve leaves the eye, and the fovea, which we're going to come on to now. The retina's got many light receptors. You've got two different types of receptors in your retina. You've got rods, which detect light, or lack of it, and cones, which detect colours. You've actually got three different types of cones, red ones, blue ones, and green ones, that detect the three primary colours of light. The retina's got an amazing blood supply, as you can imagine. Now, the fovea is the point with the greatest density of light receptors, so you can think of it as kind of like directly behind where your pupil is. It's got many different light receptors which allow you to have a very good quality, clear image if you're looking directly at something. Now, how does it actually work? The lens and the cornea refract the light, they bend it to focus it onto the retina. This is what would happen in a normal situation. Now, if this were to happen, as you can see, the focal point is before the retina. The rays of light cross before they get there. Therefore, when they arrive to the retina, the image will be blurred. Let's look back at how it should be. You can see that the exact point where the rays of light cross is on the retina. This will produce a nice clear image. And this won't. So, for near vision, when you're looking at something very close, the light has to be refracted more just because the angle that it enters the eye is larger. What will happen is the ciliary muscles will relax, and therefore the lens becomes fatter. You can see here it's very wide. The fatter the lens, the more the light is refracted. If you're looking at something from far away, the light needs to be refracted less. Therefore, the ciliary muscles contract, and you can see that they change the shape of the lens. The lens in this picture is much thinner. This means it will refract the light less. Here's a little animation just to show you what happens as the ciliary muscles contract and relax to change the shape of the lens. It's also very important for your eye to control the amount of light that goes in, because too much light will damage your retina. Therefore, that's what your iris is for. Your iris, is the coloured part of your eye, is actually made of muscle, and these muscles can contract and relax to make the pupil bigger and smaller. All the pupil is a hole through into your eye. In low light levels, the pupil will become larger to let more light in to help you to see better. When there is a lot of light, the pupil becomes smaller to prevent damage. And here's the bibliography. Thank you.